the bar magnet and all important that Gauss law. We have studied that Gauss law in electrostatics also. Now this one is a little bit different for this case. Now we know that that bar magnet will act as an equivalent solenoid. Yeah, so solenoid, that is obviously you can say that, which will act as a magnet when that current is going to flow through that coil, and obviously you can say that it will act as a that magnet. So that property that you're going to use, or it will act as a magnet. Then next thing, so how should I define this, your Gauss law? So let's say that for this case, if I just consider that this is nothing but, now obviously we know that the magnetic field, so let's say that this is the current carrying conductor, and which will produce the magnetic field around it. Yeah, so if I consider a very small part of this over here, yeah, so now this area is nothing but ds, and what is the net flux, what is the net magnetic flux that is going to pass through this your surface, so which I kept over here. So this surface is obviously having the two sides, that is in both the direction. Now I can say that, so for this the field is coming like this, and again which I have shown the direction for this. So then this is nothing but the ds, this is nothing but the direction for your magnetic field. Again for this one also you can just show that the direction for your magnetic field which is incoming. Fine. So now this flux that we are simply saying that, which is the integration of your b bar dot ds bar or b bar dot, that is the dA bar. So any notation you can use. Now if you observe from this diagram, so the direction for your b dA, and that is a minus b dA. Yeah, fine. So for the first thing it is having the same direction, and for another one it is having the opposite. So that is a BdA minus BdA. So obviously which will results in the value of flux which is equals to 0. So you can say that the magnetic flux through any closed surface is always equals to 0. So that is also along the proof that you can say, so which indicates that, and which is different as compared to your electric field. The Gauss law related to the electric field is different, which states that charge, which is nothing but, you can say that the flux passing through any closed surface, which is 1 upon epsilon naught times the charge enclosed by that surface. But here it is different, here it states that it is 0.